Okay, so a plane, you need a point plus two direction. Okay, plus two direction. So one direction use lambda, one direction use mu. Okay, you can use s and t, it doesn't matter. The two direction, right, need not be on the plane. So as long as it is all parallel to the plane will do. So something, yeah, okay. So you need a point and two direction. Okay, go to the next page. Okay, yeah. So for example, A, the plane has a point. So can you see this point is here? Okay, it's parallel to this. This one is D1. Okay, and then this one is D2. Okay, so you have a point and two directions. So that's very good for you. You must always start with R equals to, okay, write down, this is 1, 2, 0, or plus lambda 1 minus 1, 1, plus mu 2, 1, 2. Okay, so you have two direction over here. Yeah, then remember to write lambda and mu are a real number. Okay, can? So that's simple. Okay, so for B, okay, I want you all to know how to draw a plane. Okay, so draw a parallel. Always when you draw a plane, right, always draw a parallelogram like that. Okay, and then this is like P1. Okay, so P1 has a point A here. It doesn't matter where the A is. So A, which is 3, 1, minus 1. Okay, then it also has a line. Can see it also says that there's a line here. So you draw a line. So a line has a point which is 420 because this is the point, and then this is the direction. Okay, as well as a direction 2, minus 1, 3. Okay, so you need two direction. So the first direction you already have, take from the line, which is 2, minus 1, 3. Okay, the second direction you need to take 2 points. Okay, so label this as B. The second direction, just take 2 points to form one direction. That would be 420 minus 3, 1, minus 1. The other way around also can, doesn't matter one. Okay, then you will have 1, 1, 1. Okay, so the equation for P1 dot dot always start with R equals to, now take a point. Any of the 2 points can, 420 can, 3, 1, minus 1 also can. So I take 420. You can take 3, 1, minus 1 also, doesn't matter. Plus lambda, first direction, 2, minus 1, 3. Plus mu, another direction, 1, 1, 1. Okay, yeah. So again, it's a point as well as two direction, or if it includes the line. Okay, and for C, again, let's draw a plane. Label this like 0, 1, 1 first, and another one which is minus 2, 1, 3, and another one that is 2, 0, 1. Huh? Yeah, then the plane passes through the point, means the point is always on the plane. If it passes through the point, then the point is there. You know what I mean? Yeah, it will. Passes through the point means it will, the point will be on the plane. Okay? Can? So you need the first direction. So D1 equals to, now all these are points. Are they direction? No. So we need to form direction first. Minus 2, 1, 3, minus 0, 1, 1. Okay, that will give you minus 2, 0, 2. Okay, so direction can simplify. Take out a 2, you have minus 1, 0, 1. Take this as the direction. Okay, always take the simplest form as the direction. Coordinate cannot simplify. direction can simplify. Okay, so I have D2, which is another 2 point. This will give me -4, 1, 2. Okay, yeah, so now we have 2 direction already, right? Yeah, we can say that P1 is R equals to any point will do, any of the 3. So 0, 1, 1 plus lambda first direction minus 1, 0, 1 plus mu second direction -4, 1, 2. Okay, remember to say that lambda and mu are real number. Okay, can? So a point and 2 direction. Take 2 points to form a new direction.
What is the parallelogram drawn on stand for?
A plane, no? A plane.
So all the lines
Yeah, all the points lies on the plane. Even if it doesn't lie, right, you can also use. Okay, so for example, you write down D. Okay, you write down D. Okay, contain a line R equals to 1, 2, 3 plus lambda 5, 6, 7 and parallel to another line R equals to 1, 0, 1 plus mu 8, 9, 10. Okay, yeah, so in this case, the plane, right, contain this one, a line. So this is L1. Okay, but parallel to L2. This is L2. Okay, write down this is L1. And write down this is L2. Okay, yeah. So you can use the direction. This one, come write down. This is D1. This is D2. Okay, but the point you can only use 1, 2, 3. Understand or not? You cannot use 1, 0, 1 because 1, 0, 1 doesn't lie on the plane. Understand? Only 1, 2, 3 lies on the plane. So therefore P1 is R equals to 1, 2, 3 plus lambda 5, 6, 7 plus mu 8, 9, 10. So you got direction. The direction, as long as it's parallel, you can use, but the point must be on the plane. Okay, so you can put a point here. This one write down as 1, 2, 3. Okay, and then this one is like 1, 0, 1. You cannot use 1, 0, 1 right down here. Cannot use 1, 0, 1. Okay. So a point plus 2 direction is called a vector equation. Okay, it's called a vector equation. Okay, then now we need to know how to convert. Okay, so the first part is a plane has a point plus 2 direction. Okay, that's called a vector equation. Okay, so now a vector equation, okay, can convert to a scalar dot product form. Okay, important, this part means write down every plane have a normal. A normal is perpendicular to the plane. Okay, so we usually represent a normal. Okay, represent the plane with a parallelogram as well as a normal that is 90-degree perpendicular to the plane. Okay, and how to get normal? Right now, normal is equals to D1 cross D2, not multiply, but cross. Okay, can yeah. So this second form is called R dot N equals to A dot N. So you need write a tick, and then you need a normal as well as a point. Okay, this A dot N will give you equals to a constant D. Okay, so that's why usually we write as R dot N is equals to D. So for example, so write down example is like R dot 1, 2, 3 equals to 5. This is the another way of writing an equation, okay, of the plane. Then 1, 2, 3, you must know that if R dot 1, 2, 3 equals to 5, right? Then 1, 2, 3 is called the normal. And what is a normal? A normal is a line, a direction that is perpendicular to the plane. Okay? The normal doesn't just exist there only. It can be everywhere, is still the same normal. So for example, the normal can be here, right? The normal can also be here. The normal can also be here. The normal is everywhere. It's still the same normal because the direction is always the same. Okay? Okay? So how to convert this one to become a R dot N equals to D form? Okay? Always know that, draw a parallelogram first. Okay? This is 1, 2, 1. This is minus 1, 0, 2. And this is 3, 1, 0. Okay? So how does the normal look like? A normal, draw this upwards like that, perpendicular. This is normal. Listen, guys, please listen, please. Okay? So a normal is always take two directions, cross each other. Okay, so remember our cross product. Cover the first row, 0 times 0 minus, so 0 minus 2. Cover the second row, put a negative first, or downward cross 0 minus 6. Okay, and then cover the third row, minus 1, minus 0. Okay, so the normal is minus 2, 6, minus 1. Okay, so this is a normal. This is, yeah, they're perpendicular to the plane. Perpendicular to two vector. Okay, and so this is the normal. So now I want to put it in dot product form. I boxed up the dot product form. This means R dot N equals to A dot N. Okay, so R is always R. R dot normal, negative 2, 6, minus 1 equals to A. A is a point. So what is a point that lies on the plane? Can you use 310? Cannot. 310 is a direction. Can you use negative 102? Cannot. That is also a direction. Can you use 121? Can, because that is a point. 121 dot negative 2, 6, minus 1. So the answer is R dot minus 2, 6, minus 1 equals to, let's dot this, minus 2 plus 12 minus 1. So I will have R dot minus 2, 6, minus 1 equals to 9. That's the dot product form. That's another form of writing, okay, on the plane. And whenever you see R dot something, this one, R dot something, this one is called the normal. Skip that one first, sorry. Later I come to you. Let's skip that one first. Yeah, sorry. Okay, can? Now, this determine another point. This one. Okay. Make sure you have space for this. Put a star down here. Infer a point. It's a very important skill that you must know. Okay, so for example, if I have write down r dot minus 2, 6 minus 1 equals to 9. Okay, it's like a trial and error. It's like anything actually can do. Okay, then you write down. Okay, so if I want three things, right, dot minus 2, 6 minus 1 can give you equals to 9, right? Okay, then this point will lie on the plane. This is a very important skill. So I want to have like minus 1, 1, and minus 1. Okay, so this 3 point, right, is observe right now. Observe. Okay, it's really just by observe. But actually later on, I'll teach you how to use 0, and 0 is always better. Okay, so minus 1, because when I dot like that, right, this will give me 2 plus 6, right? Then plus 1, right? Not? Does it equals to 9? Yes, right. So therefore, minus 1, 1, minus 1, lie on plane. So this is a skill super important. You must own self know how to observe and determine the point that can lie on the plane. Yes. Okay. So basically the X, Y, Z, right, is you own self decide for yourself one. Okay. If you still have space, then maybe the best way is to try to use two zeros for something. So for example, I don't know where you have space. Are you done? Okay. Cheng, you still there? Cheng, are you there?
Yeah.
Okay. Okay, so I want to teach you this skill of how to infer a point. So look here. Okay, infer a point, right, can always come when you have r dot something. So let's say just now that question, r dot minus 2, 6 minus 1 equals to 9, right? Okay, actually the best way, right, is use 0, 0, negative 9. Yeah, try to make two things 0 is always the best way. Okay, why is it so? Because zero, 0 minus 9 dot minus 2, 6 minus 1 will all give you 9, right? Not yeah. So always set two things as 0. Okay, that is usually the easiest way. Okay, so infer a point is like super important, super good to use. And if your can see over there, I sneak in this. D is a constant. If the plane contain origin, origin is what? What is the coordinate of origin? 0, 0, 0. So 0, 0, 0 dot anything will always give you 0. So that's why the D is 0. Understand or not? So if you realize that, or if the question give you r dot 1, 2, 3 equals 0, right? It means 0, 0, 0 lies on the lies. R is just a variable. Okay, R is just a representation of the line or plane. Okay, R is a representation of vectors in 3-dimensional form, just like that. R is always a variable, it's X, Y, Z. Okay, R always means X, Y, Z. Okay, R always means X, Y, Z. Yeah, correct. Okay, so first at the start, we have vector equation. We consist of 1 point and 2 direction. Okay, if we have 2 direction, how can we make to become a normal? We cross the 2 direction to make the normal. Okay, and then to represent in r dot n equals to a dot n form, or you need another point also. Okay, so r dot n equals to d. Okay, and then learn how to infer a point by using observation. Okay, this skill super important. Okay, yeah. Then the last one is called Cartesian equation, means write down ax plus by plus cz equals to d form. Okay, so just remember R means X, Y, Z. Huh? Constant. Constant, yeah.
D is what, like?
Constant, a number. Okay. So R always means X, Y, Z. Okay. So if I want to convert this, I want to convert this. This was just now my dot product form, right? Equation, right? Yeah. So R means X, Y, Z. So write down on top. X, Y, Z dot minus 2, 6 minus 1 equals to 9. So you just dot out lor. So negative 2x plus 6y minus z equals to 9. Okay, so just dot out. R means X, Y, Z. Okay? Yeah? Can I'm going slowly, but don't worry, I will be, yeah. Oh, okay. So learn how to draw an XYZ form. Okay. Draw this, and draw this. This is X, this is Y, and this is Z. Okay, I'm just going to do one. Okay. So can see this is YZ plane. Oh, where is the YZ plane? I shade this YZ plane. Okay, can YZ plane will pass through 0, 0, 0. So that is one observation. Okay, as well as the x-axis is perpendicular to YZ plane. Okay, so remember x-axis got a direction vector of what? Jonas? Very good. So 1, 0, 0 is the normal. So many students screw up vectors because they don't draw and see or try to understand how the drawing tells you. Okay, so what I'm doing is trying to show you how the drawing tells you. Okay, so R dot n, the n is 1, 0, 0, will equals to 0, 0, 0 dot 1, 0, 0. So therefore, the YZ plane is R dot 1, 0, 0 equals to 0. Okay, maybe this part a bit hard to understand. The x-axis is perpendicular to the YZ plane. So if you draw out this whole thing, right, all these are perpendicular. Can you see our x-axis is always perpendicular to y-axis, even though I draw it like skewed, like not okay, like not really 90 degree, right? But because this is like 3-dimensional, and this is also perpendicular to this. Scalar product is the same as dot product. So yeah, it's the same. Scalar product means dot product. Okay, can so go to the next one. Okay, are you ready? No? So look up here. Okay, look up here. Convert these to scalar product form. What a scalar product form means? R dot n equals to D. Okay, and what is parametric form? Point plus lambda D1 plus mu D2. Okay, so this is a very big skew. X minus y plus 2z equals to 3, right? So remember, R means what? X, Y, Z, right? Okay, so I can pull this out. I can pull X, Y, Z out here. Okay, what would be the vector that accompany this X, Y, Z? Matt. If I can pull X, Y, Z out as a vector, what would be the vector here that accompany the X, Y, Z? One minus 1, 2. Yeah. Okay. So this is called the reverse of dot product. Okay. Equals to 3. Okay. X, Y, Z means what? R dot 1 minus 1, 2 equals to 3. X, Y, Z. R will always be there. R will always be there. Okay. R is any point on the plane, actually. Okay. Oh, can? Okay. So let's say, again, I want to say infer a point. The question will not ask you to infer a point one. You must own self know when to infer a point. Later I'll talk to you. Infer a point. Okay, Angelina, tell me what is one point that will lie on a plane? One? No, 1 minus 1, 2 is this is a what? Guys, this is a what? Yeah, some more. R dot what? The thing that the vector that comes with the R is always the what? Some more, what direction? Normal. Okay, it's always a normal. Write down, write down. I know this is the first lesson for y'all. So remember, R, because it's always R dot N. So this guy is a normal. That one is not a point. So tell me, what X, Y, Z can satisfy this? 3, 0, 0. Very good. Yeah, Angelina, you say what? 0, 0, 1 cannot. You look. 0, 0, 1 dot 1 minus 1, 2. Does it give you 3 or not? Yeah, you must on this one. 3, 0, 0 is a very good one. Okay, another one, Jonas. 0 minus 3, 0 also can. Yes, correct. If I don't want 2 zeros, then 1, 0, 1 also can. Understand? Any three. So this skill I teach you all first because it's very useful. Okay? Okay? Can? Then draw a line. Parametric form is a little bit harder. Okay, so when you want to convert this to parametric form, right? It's actually seldom the question asks you. Okay, so right now, let Z equals to lambda. Okay, and let Y equals to mu. Okay. So I will have X minus Y plus 2Z equals to 3, right? Give me a second. Okay, so this means that X equals to Y minus 2Z plus 3. Can see? So this guy means that this is mu minus 2 lambda plus 3. This one is hard. Okay, yeah, put star here. But actually seldom they will ask. I just put it here first. Okay, so Y equals to mu ma. Then Z equals to lambda ma. Because I already let down there. So X, Y, Z is equals to, so put it in order, 3 plus mu minus 2 lambda, Y equals to mu, and Z equals to lambda. then you can form x, y, z means what? R, very good. This will be 300 plus mu 110 plus lambda minus 201. Yeah, this will be your original one. No? So this one is a D1. This one is a D2. Oh.
Why you choose Y and Z?
Oh, doesn't matter one. You can choose X. You can any two. Doesn't matter, any two. Okay, any two will do. Okay, because you must know that in a parametric form, you must have a lambda and a mu. You can just let either X or Y, XY or XZ or YZ. Any two of the three can. Okay, but not common. Not common actually, this kind of question. Okay, so how many form of a plane you know? Okay, let's revise. The first kind is okay, so how we write the plane, like P dot 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 means such that R equals to, no need to write, just refresh with me, a point plus lambda D1 plus mu D2. Okay, this is called a vector equation form. Okay, the second form would be R dot N. Okay, yeah, equals to a constant D. And how to get N from the two direction? D1 cross D2. Well done, guys. Okay, and the third one would be, because R means X, Y, Z, so X, Y, Z or dot 1, 2, 3 equals to, let's say your D is 5, example 5. Okay, then we will say that this is X plus 2Y plus 3Z equals to 5. Okay, so there's three kinds of form, okay, for plane. Cartesian equation. Okay, so let's go back and review a little bit. So remember your line. Okay, so remember your line. So the easiest way of representing a line is R equals to, let's say 1, 2, 3, or plus lambda 5, 6, 7. Okay, so this is called a vector equation form, right? Yeah. So how to convert a vector equation form to Cartesian equation form? Jaden Tan, R means XYZ. So this is XYZ equals to 1 plus 5 lambda, very good, 2 plus 6 lambda, and 3 plus 7 lambda. All you need to do is to make lambda the subject. From the first one, lambda equals to x minus 1 over 5, lambda equals to y minus 2 over 6, and lambda equals to z minus 3 over 7. So the Cartesian equation will be x minus 1 over 5 equal, because all of them equal lambda, right? Y minus 2 over 6 equal z minus 3 over 7. Understand? Okay. Now, how to convert the Cartesian equation form to vector equation form for line? This one, sometimes it can get a bit tough. Like x minus 1 over 5 equals to z minus 3. Then they put a comma, y equals to 0. Okay? So if they put a comma, means got no lambda. When they are equal, means they are equal to what? Lambda. Yes. X minus 1 over 5 equals to lambda. So this means that x equals to 5 lambda plus 1. Or z minus 3 equals to lambda. This means that z equals to 3 plus lambda. Okay? And then I have y equals to 0, right? So put all this in x, y, z form. X, y, z equals to, always put number in front. 1 plus 5 lambda. Z equals to what? 0. Sorry, y equals to 0. Then this is 3 plus lambda. Then break up into 2. Tell me what is the point here, Angelina? Plus lambda. Can like that, understand, guys? Okay. So must be very clear what is a line, what is a plane. A plane is a piece of paper. A line is a line. Okay? Can you understand now? Can you understand so far? Yes, right? Later I will snip and put in the group chat. Okay? Yes.
When like you equate two equations together, and you have like
equate two equation is, yeah.
So like R dot the normal and then A dot normal. You just cancel both.
Cannot. Yeah, cannot cancel away normal. Cannot cancel. You must evaluate. Always evaluate. Okay. Can? So next one. Okay. What is the relationship between a line and a plane? I think before I okay, talk about this, right? Yeah. Okay. See, number one, if so there's two things, a line and a plane. There's two things, okay. So first, I want you all to draw a plane for me, which is a parallelogram. Come draw a plane for me. Okay, guys, really just be focused with me. Can?
Yes.
I ask you to draw. You do you draw? Okay. A plane will always have a normal. Okay. So remember, a line will have a point. So this is A plus a direction. Okay. So if a line lies on the plane, firstly, can you see the then the normal will be perpendicular to the line. Okay. So remember, on top, I want you to write down, if two vectors perpendicular, what was the concept? Cheng-En, can remember or not? If two vectors are perpendicular.
The line equation.
A
like you
dot,
thought then it equals to 0.
yes, correct, very good. If two vectors are perpendicular, then A dot B equals to 0. Okay, so that's why the direction of the line dot the normal will give you equals to 0. Okay, and your A dot N satisfy the constant. Okay, so underline the perpendicular. And if A lies on the plane, right, this means that A dot N must give you equals to D. Okay? Can? Don't worry first, just understand the relationship first. So again, I just want you all to practice to draw a plane. Okay? Ryan, a plane always comes with a what? Yeah, so that direction is called a normal. Okay, so when you draw a plane, always draw the normal. Understand? When you draw the plane, always draw the normal. Okay, can? Now you draw a line here. Label this as L. And then A and a D. Okay? The line does not lie on the plane. Okay, but the direction will still be perpendicular. Yeah, so D dot N will still give you equals to 0. But A dot N will not be equals to the constant. Okay, because the point does not lie on the plane. So remember just now, Angelina tell me 0, 0, 2. I try to dot it and then it's not equals to 3, right? Yeah. So as long as you dot and it's not equals to the constant there, right? Means it does not lie on the plane. The number that is behind, like there. This is the D. This is the constant, yeah. Okay, this is the constant. Yeah, verify that this point is on the plane. Yeah. Okay. Questions of vectors is actually very broad. Okay. And so usually the last one is if the line intersect with the plane. Again, now draw a plane. The plane must always come with a what? Normal. Okay. Yeah, the plane must always come with the normal. Okay. So now draw a line here. So a line has, now the point A not necessarily lie on the plane. Okay, if you can observe that it lies on the plane, then good for you. If you can reach that level, yeah. Okay, a point plus a direction. Okay, so in this case, yeah, R means X, Y, Z. Okay, R means X, Y, Z. R is called a point. Okay, now a point can be part of a, okay, I don't want to confuse you first. So first write down, let's say P1 is, so this is P1. R dot 1, 2, 3, okay, equals to 5. Okay, then now let's say L1 is R equals to 101 plus lambda 111. Okay. So label this as Q, big Q. Let Q be the point of intersection of L and P, P1, L1 and P1. So first thing is, because remember when we do the foot of the perpendicular, right? Yeah, because Q is on the line, right? Yeah, so this Q again, many students don't know, is that OQ is equals to 1 plus lambda, 0 plus lambda, as well as 1 plus lambda. Where does this come from? This all comes from the line. Here, this, can see? Can see? So remember when we do the foot of the perpendicular, right, as long as any coordinate lies on the line, right, you can use the whole equation of the line. Okay? You can use the whole equation of the line, right? Yeah, as the coordinate. So your job, you know now, is to find the lambda. Okay? And you always start with O, with respect to O. Okay? Yeah. So can you see that this one means XYZ, right? This one means XYZ. Yeah, this one is labeled as equation 1. Okay? As well as, so R dot 1, 2, 3. So again, we are trying to solve simultaneous equation equals to 5. Equation 2. Or sub equation 1 into your R. So this means that 1 plus lambda, so the 0 we don't need to write, lambda, and 1 plus lambda dot 1, 2, 3. Because n is a point on the plane, then n can put into the R, equals to 5. So now you write 1 plus lambda plus 2 lambda plus 3 plus 3 lambda equals to 5. Six lambda understand? So therefore OQ equals to 7/6, 1/6, 7/6. Sub back into 1.
So the intersection can be on
Plane, yeah, correct.
it doesn't need to be at the border of the
No. Yeah, no. Because the plane is very big. It doesn't matter where you draw the Q, actually. Of course, you can draw it at the border. No. Okay, so yeah, the plane is when we talk about plane, right, is anywhere around here. Understand? The whole place. It's not just border. You know, it's on the whole piece of paper. Here, it's on the whole piece of paper. Yeah. Okay. Okay. Yeah. So this is how we find the point of intersection. So y'all keep asking me what is R, right? So R means XYZ. XYZ actually means a point that is either on the line or on the plane. Yeah. If you all feel that that is better, okay, then remember, write down somewhere. R equals to point on plane or the point on the line. Can. Line or any line, yeah, not plane, no, yeah, either plane or line, yes. Okay. So maybe okay. Maybe I will skip this part first. Your 15.6, right? Leave it blank first. Okay. Go to the next part. Okay. Right out here, put a star here. To find the distance of a point to a plane. Okay, so this is something, okay, I saw in some of your tutorials that is, okay, I forgot to put this inside. Okay, so for example, okay, find the distance of P 1, 2, minus 1 Okay, so this is actually a very important skill, okay, that you need to know. Okay, so number one, okay, now you must identify that this 111, right, is the what of the plane. So this is the plane, right? 111 is the what? Is the normal. Very good. Okay, so I will draw a plane here. Okay, draw a normal. Okay, always write down, label P on top of the normal. So which means that P is like here, 1, 2, minus 1. Okay, can then, so remember the normal. So this is the normal here, right? Which is right down here, 1, 1, 1. Okay, can. Number 2, infer a point on the plane. So the point is equals to, Angelina, tell me what is a point that could lie on the plane. Very good. Or a point on the plane is called 300. Okay. So to find for point to plane, right? So always label the P on top first. Okay, always draw a plane with a normal, then label the P that is on top of the normal. Okay, if you don't label the P that's on top of normal, right, then you very hard to solve. Okay, so number 2, infer a point that's on the plane. So we label this as Q lah. Okay, so now basically Q is here. You can label this as 300. Okay, can. Now 3, QP is the vector of the hypotenuse. Okay, which is 1, 2 minus 1 minus 3, 0, 0. Okay, QP is P minus Q, right? Yeah. So that would be minus 2, 2 minus 1. Okay, can? So do we have two vectors already? We have two vectors, right? One is QP and one is the normal, which is the direction, right? Okay, where is the angle that the two vectors make? Very good, over here. Or number 4, label the theta. Because the normal, okay. So the good question is, label theta, not Q. This is theta. Be careful. Label the angle theta. Okay. So this is one. So this is one thing you all must understand is that the normal, right, is everywhere one. Okay. So you see, P is here, right? So when students draw normal, right, they don't draw the normal connecting to P. Then very hard to form the triangle. Understand or not? So this is a normal. This is a norm. The normal is not fixed at one place. The normal is everywhere coming out from the paper. Understand? Okay. This is also the normal. But if you don't draw the normal to the P, right, then you cannot solve this question. Okay. So now looking at this, so remember we do the length of projection, all this. So number 5, the shortest distance of P to plane So now you look, remember in vectors 1, when we do shortest distance, it's always the opposite direction. It's always the opposite side. Then we use sine and we use cross, right? But now can you see the angle is here? Where is the floor? Okay, so I'm going to draw. Yeah, okay, very good. So look here, as long as you draw this, okay, I'm going to draw this over here. So we already have all this. So Q is here. And then I already have this one. And then I already asked you to draw theta, right? Okay, so remember back to vectors 1. This is the floor, right? Not? This is the floor. So the floor has a direction. Okay, and then we have a point here, which is P. And then we have Q here. Can you see? Okay, so if I want, and then the angle theta is here, right? Not? Because it's the angle between two vectors. Okay, if I want the shortest distance from a point to a line, he's talking about this one, right? Right. This one is opposite or adjacent? Opposite. So this guy, the perpendicular distance, the formula is hypotenuse QP cross D hat. Okay, remember perpendicular distance. So this triangle must be very familiar. Okay, then remember, what is this called? The shadow on the floor is called what? Length of projection. So the formula for length of projection is the modulus of QP dot D hat. Right now. Okay, can? So now, okay, so this is called the perpendicular distance from point to line. This is called the projection vector. But when it comes to plane, you realize that the plane is useless because the plane is always represented by the what? The normal. So if I want to find this, we are using dot or cross. Jaden Tan say dot. If you want to find this, yeah, we're using dot or cross. Look at the angle. Is it adjacent or opposite? Huh? Adjacent. Adjacent use dot or cross. Yeah, so it's dot. You're correct. The floor is who? The floor is who? The normal and hat. Okay, so that's why when it comes to plane, right, everything is actually just, later you'll realize that it's just all the opposite. It's equals to, write down, QP dot N hat. Understand? Because when I want to find the distance from plane to line, yeah, here. Can see? Okay, give me a while. Let me print something. Okay. Don't worry. Later we will get to practice. Some of the okay question.